Hey, what's up? It's Paul Solt. I just want to talk about protocols, associated types, and their constraints and generics. This was on the code challenge, which made it harder to understand. And so it's just understanding how these associated types work. So Paul Hudson goes over this in his lesson on associated type. And he talks about the type being like a whole that I guess you fill with another concrete type. So here we have a protocol for a screen with an associated item type, and we're going to have an array of items, item type items. That's get and set. So this screen, so then we can implement a screen with a class, and then you can explicitly say type alias item type is equal to string, which then sort of fills the whole of item type with string, and then you can use string in it. But then Swift is smart and it can figure out the type alias on its own. So down here at the bottom, if you just create the items, this is actually fulfilling, or this is setting the item type, which I never fully understood. And I still struggle with this a little bit, but I understand the point of we want to have strings. And I think this is where Swift is a little bit confusing, like with generics versus protocols, because there's this like second layer of things that you can do that with lightweight generics and C++, Objective-C, you didn't really have. And I've always found this code a little bit confusing. So having this on the code challenge made the code challenge a little bit more confusing to get working. And I ran into some compiler errors that definitely threw me for a loop. So this is something that I would definitely brush up on because it seems to be a common theme across a couple of the code interviews I've done. So here we have a protocol of items. The items has an init that takes file names that are strings. So then you can conform a type to that by just having a file name. How does that work? Is this a typo? It doesn't actually have file name. There's an init. Is that possible? Is there a var? I never saw him define file name, so I'm a little confused how this is even possible to create an instance variable. I think you still need the get set for file name in order to make this work. I don't know. Let's find out. Does that implicitly make file name? Oh, it's because it's a structure? I have no idea. I've never seen this happen before. This is okay. This is the weirdest thing. I've never seen this before. So one of these could actually have properties and the other wouldn't. So then we could conform this one with number. So that won't work. But if we create I don't know. Let's go Numb from Linkin Park. Oh, whoops. Okay. I think that's a little obtuse, to be honest. Like, if you're gonna, this should just be and then right? Like, this is explicit. This is like implicitly makes variables, which is weird. Here we're being explicit. So that makes the most sense to me. This is weird. Because then this is what I would expect. That you actually have values. So that is protocol conformance, and then so we're conforming to a type. So then if we had an associated type and we're now restricting it to just items, so we're having some kind of entity here, and this is where we're like almost blurring the lines with generics, but it's not quite generics. This is just protocol type system logic. So down here we can have a screen, and screens can have movies. So we're conforming to screen, and so by having movie here, and we say that we have items of item type, the items have to be of type item. We scroll back up, we see that movie is an item, so it has a file name so that it can be initialized, so that we can find it. And then we can do recursive constraints, where you have a child screen. So you could have a type, and this requires a class. So you can't do this with structs, and this was also released in Swift 4.1. So with this, item type of items, and then child screen of type screen. And so we're a protocol that is defining ourselves as having some kind of thing. So if this was a node type, you could potentially have like the next node defined with this mindset. And we're just associating types. And he talks about it as filling holes that you, I guess, plug in with a specific type. So the items isn't going to be an item type, and we're going to say it's going to be a movie. So that means that items is movies, which we know get a file name to create them. And then child screens is another screen, and this is our main screen. So child screen has multiple main screens, which I don't really know what that means in terms of what we're getting at from like a conceptual standpoint, but we're just trying to create an example here. And then you can get into a situation where maybe you can mix and match types incorrectly. So if you had all of these be movies using the protocols, it would be possible to change category screen. So if we're drilling down from main screen to category screen, and category screen to detail screen, and detail screen to detail screen, then you could run into a situation where you write it as category screen of songs. And so now we're switching types from movie to song to movie, which might be incorrect, and you could get the compiler to warn you about that. This is where I don't like the compiler always telling me things are weird, and maybe it's just a matter of understanding associated types a little bit better. But what you can do is you can be explicit and say, okay, child screen has to be a screen where the child screen.item type is equal to item type. So it has to be the same item type. And you can get back up to item type, which is we've got our item. And item type is going to be implicitly, up here is item type is defined on this screen. So a screen has an item type, which is implicitly understood once we did the protocol conformance here for movie. And then associated movie and item. We said we had an item type of item, and we have an array of those things. So back down here, we can take it one step further, and this is where we're actually using generics and not just protocols and protocol conformance and associated types, which almost feel like generics to me coming from Objective-C mentality. But now we have generics where we can actually have mix and match different types of things at compile time. Actually, I don't know how generics work in Swift compared to Objective-C, because in Objective-C, it's just kind of like lightweight. They don't actually translate into Swift. They are just to help with the compiler at compile time, and then they sort of disappear. Here, we can make it so that we're not locked into just one type of movie. So up in this example, we locked ourselves into the movie type with the main screen, the category screen, and the detail screen. All of these were movies, but if we wanted to support podcasts and TV and movie or show, then we need to have a generic type. And so the generic type is just a placeholder for something that is of type item. So we're kind of we're specifying that in these angle brackets. So we're saying we're going to have a generic type of T that's going to conform to the item protocol. So then we know it has to take a file name, and it supports doing something like a song, movie, TV show, etc. So we then store elements, generic elements of type item, and we have screens that are generic of category screen. So that's our protocol. And then that's our concrete class. Category screen has items as well, and then your child screens have detail screens, which is a concrete class of type screen. So these are all conforming to screen, which means that they have items and they have child screens, but now they're all generic so that we can have these custom types. All right, so this was just a run through of just me trying to remember protocol types and their constraints, and then getting into generics because it's been fuzzy. I just wanted to refresh my memory because in this code challenge, I've got exactly that. So this code challenge has a cache, and it's doing this conformance, and this is actually setting the associated type to type string or to type int, and we're extending those classes to become cache items. So I was just trying to wrap my mind around exactly what this is doing. So we have an associated key here, type that has to be hashable, and then we have a variable that is of type key that is hashable. So that's our cache item. And then we create a key and conform string to this, and this sets our associated type to type string. This sets our associated type to type int, and then we're returning our actual value rather than like a movie or a image. Like this is just a easy example of storing a string or an int as the actual key. Then we have the cache interface, and yeah, so that is the code challenge. I'm going to work on this next, but I just wanted to break down in my mind like what's going on here before I start again, so that I'm not as leery of this code. Like when I first saw this, I was like, oh crap, I haven't brushed up on generics or like these complex protocol conformances that I always feel like I'm fighting against. And maybe you feel that same way. Like when I'm trying to write Swift code, and especially if I didn't write the original code, trying to get the code to compile is probably one of the most frustrating things I have with Swift compared to Objective-C. Like Objective-C doesn't have as many rules, doesn't have all of this like compile time safety, which adds some overhead and complexity. So if you want to be a better programmer, you have to take some time to just make sure you're understanding some of these fundamentals. Even if you've been doing it for years, even if you've been able to get the code to compile, like trying to understand what these core concepts are. And I think hacking with Swift is really good. If we just look at Apple, they probably have some really good topics. So they've got generics. Swiftly is another good resource. So I might open that one up. Command clicking on links will open them up in separate tabs. So just going through some of this, like I might even just go through all of this guide on some of this stuff, because Apple keeps changing things and there's little nuances, and I want to make sure I understand some of those nuances, especially around type constraints. Like this is part of the complexity of Swift, and this is what I'm always fighting, is what type is it? And my mental model of types is, I think, a little bit lacking in sometimes, and it's like fighting the compiler and then not really understanding why it worked. I think would help to understand. Like I understand the concepts, but sometimes it's just frustrating to work with. So I think protocols comes right before that. And there's rules about protocol extensions, inheritance, class-only protocols, protocol composition, protocol conformance, Objective-C interaction, optional, a lot of stuff here. So if this is helpful, click the like button. If you want to learn more or have some suggestions for resources, just let me know. Thanks for watching.